So we're going to go through more examples of naming alkanes, and we'll continue the series through some other videos as well. But starting with a series of molecules, we're going to start with the longest carbon chain. And so if we go through and figure out the longest carbon chain like this and circle it, what we can see then are the side groups that start to hang off. And this forms our basis for naming anything. What we want to do now is try to figure out the length of the carbon chain. So if we were to count the number of carbons, 1, 2, 3, 4, 5, 6, we can call this a hexane. And now we know that we've got some substituents hanging off. There is a methyl group here and a methyl group here. And so I'm going to write those down so that we don't forget. So I'm going to say there's a methyl group, but I'm also going to write down the other one. I'm not going to skip any steps here. So there's two methyls. Now we need to number where those methyl groups are on the carbon chain. So we know we have 6 carbons in a row here, and so we're going to start from one side or the other. So we have to decide, are we going to start from here or are we going to start from here? And now, given that these two alkane groups are essentially equivalent, we're going to try to figure out which one is closer to the end. So if I count in 2 carbons from here, I see I got a methyl group. If I count 1, 2, 3 in from this end, I start at a 3 group. So I've got the potential that I could start from here 1, 2. So one of my methyl groups is a 2, and one of my methyl groups is on the 4 methyl. If I start from the other side, I'm going to have 1, 2, 3. So I'll write it on this side. And the other methyl group then is 1, 2, 3, 4, 5. And what IUPAC wants you to do is to choose the lower numbers. So the higher numbers here are, well, they're too high. And so IUPAC doesn't want us to choose those. So we know that starting from this side here will give us the lower numbers. So this is the side here that we're going to choose. So now to write it out, I need to combine everything together, including the the parent chain name here. And so I could write out 2-methyl, 4-methyl, hexane, but you can see that's a bit redundant. So what we're going to do is combine this together to kind of make it a little bit easier for ourselves. And I'm going to give myself some space here. And so if we say on the 2 chain, I have a methyl group, and then I'm going to put a comma. So between numbers, we use a comma. On the 4 carbon is another methyl group. I'm going to use a dash line. The dash is between numbers and letters. There are 2 methyl groups, so I'm going to use the term dimethyl. So that tells me that there are 2 methyl groups. One of them is on the 2 carbon, one of them is on the 4 carbon. So 2,4-dimethyl hexane. This is all one word right here. Moving on to the next 2 examples, we see we have the same carbon chain again. So for this molecule and this molecule, but what I want to point out is that we've got a methyl group on and a chloro group, and again a chloro and a methyl group. And what I've done is I've switched around their positions on the chain. And I want to point out then that this is what we're going to focus on for the naming for this part. So if I go ahead and name the carbon chain in both cases here, I'm going to see that I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So in both cases I have a hexane. And I have a hexane over here. And the difference then is, again, where do we start the naming? So I know that I have a methyl group, so I'm going to write down methyl here, and I'm going to write down methyl here, and I have a chloro group. So I have a chloro group, and I also have a chloro group here. And so the difference then is going to be the starting point. So on this side, I'm 2 carbons away from the methyl group. These, the alkyl halide and the methyl group, are considered equivalent. This is going to get me closer to lower numbers on the side chains. If I start from the other side here, it's going to get me higher numbers on the side chains, which we don't want. So I'm going to have a 2 on the methyl group, and I'm going to have a 1, 2, 3, 4 on the chloro group. If I start from the other side on the other molecule, 2 in here, the chloro is going to be in the 2 position, and then the methyl group is going to be 1, 2, 3, 4. So it's a 4-methyl. And we can see the difference then between the two in terms of the naming. However, when it comes to the full name, we go alphabetically. So the side chain with the alphabetically with the C comes before M in both cases. So we're going to see when we write this out, I'm going to have to do a 4-chloro 2-methyl hexane. And in the other case here, I'm going to have a 2-chloro 4-methyl hexane. All right, and we can see the difference just because of when we switched around the substituents that we got a different naming on them. So continuing on some of our examples, we're going to do this compound with the bromine and the chlorine and the bromine on the fluorine, just to show you some differences between the naming here. So again, starting with the longest carbon chain, 1, 2, 3, 4, 5, 6. So I have a hexane here. And if I start numbering, if I go 1, 2 in, I will get a bromo in the 2 position if I start here, and then if I continue, 1, 2 bromo, 3, 4 chloro. If I start from the other side, I'll get a 3 chloro and a 5 bromo. So I want the lower numbers if they're not on symmetric carbons on the molecule. So in this case here, the bromine's closer to this edge than the chlorine is to this edge. So I'm going to start here. I'm going to call it a 2 bromo. And I'm going to say it's a 1, 2, 3, 4 chloro. And then to name this, the B comes before the C. So it's a 2 bromo 2 chlorohexane. Like that. All one word, no spaces in between. If we continue to the next molecule, 1, 2, 3, 4, 5, 6 carbons. Again, this is a hexane. But the difference here, though, is that I now have an alkyl group on 2 carbons in, and I have an alkyl group, or sorry, a halide group, 2 carbons in, and a halide group, 2 carbons in here. These are considered equivalent, and so since these two are considered equivalent, which way do I start from? And now I have to go alphabetical. So the bromo, the B comes before the F, and so I'm going to start numbering from this side. So the 1, 2, 3, 4, 5, 6. And so the numbering starts from this side. So again, I will end up with a 2 bromo from this side. 1, 2, 3, 4, 5, and the 5 position is the fluoro. And that is a hexane. So to write it all out again, so 2 bromo, 2 fluoro, hexane. So I have another example here. This molecule is very similar to the previous molecule. The only difference is I've added in a methyl group. And I want to show you what that does in terms of the numbering scheme that we're going to see. So remember, when we have our carbon chain 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, in both cases we have a hexane. We're trying to figure out which side we're supposed to start our numbering from. And so if I start in 1, 2, I've got a halide here, 1, 2, I've got a halide here as well. Even if this was a methyl group, they would be considered to be the same. Same thing over here, I 1, 2 in, I've got a halide, 1, 2 in here, I've got a halide as well. And so the deciding factor now, since these are equivalent, both the fluorine and the bromine, the fluorine and the bromine, in the previous example, we relied on the alphabetical to do it. So the bromo would have won out if there was no methyl group here. But now that the methyl group's here, these two are equivalent, and now the methyl group, we move on to it, and it becomes the deciding factor. So in both cases, it now becomes the deciding factor. So in essence, we're kind of, ignoring these because they're equivalent. And so now we're starting in from this side will give us the lowest carbon numbers overall. So let's take a look at what that is going to look like. So I'm starting from this side again because the methyl group ends up being the tiebreaker here. So in the 2 position is the fluoro. In the 3 position again is the methyl, and in the 5 position is the bromo. And so I'm going to put in the 5-bromo, the 2-fluoro, and the 3-methyl will be last again. And then the hexane, all one word. This is another example of just a regular alkane chain, but what I'll point out here is our reliance on trying to circle our longest carbon chain. And so our tendency is to typically always kind of visualize and go straight across. So if I were to do this circling here like that, I could get a longest carbon chain, and I would see I would have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. But we need to point out that there actually is another way of doing this. So I can go this way and actually come down this way, and that would actually produce a 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon chain. And so both of these would be correct, but a UPAC wants us to kind of simplify in 2 ways. So the first one is they want us to create as many side chains as possible. Now that sounds kind of odd, thinking, well, doesn't that complicate things more? Not necessarily, because what we're trying to do is create the less complicated side chains as possible. So if I don't have very many side chains, that typically means that I'm going to have a bunch of atoms lumped together, and the naming of that side chain is going to typically be complicated. So to reduce that complication, if we could break up the long chain and create more smaller side chains on it, it would be much easier to name overall. So that's just something to keep in mind when we're going through this. But the point I was trying to make here is if we were to go across with our eye and circle the longest carbon chain here, you can see again that we're going to actually miss out on these bottom chains here. So please be careful when you're naming. Sometimes profs will be tricky. I'm one of them. And so if we were to count across 1, 2, 3, 4, 5, 6, 7, 8 carbons, we would think this is an octane, and we would be wrong because the longest continuous chain would be this one down here again. So start to be careful and be aware of that when you're going through. The only time that we would actually alter course is when we have a double bond or triple bond involved in the naming of the compound, because if it is, say, for example, here, a double bond right here, we have to maintain the double bond as part of the carbon chain. If we had the double bond, say, down this direction, we have to have the double bond as part of the carbon chain, and so on and so forth. So we had at different parts of the chain, the double bond or the triple bond has to be part of the longest continuous carbon chain. So let's go ahead and name these compounds then. So if I'm starting from this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, I'll just circle this. And so we know that we have a nonane. And as a side group, I have an ethyl, a methyl, and a methyl. So the question would be, which side do we start on? 1, 2, 3 in, I have a methyl group. 1, 2, 3 in, I have an ethyl group. Even though this seems like it's bigger than the methyl group, that's not the deciding factor. They're both alkyl side chains, and they're both considered equivalent. So the deciding factor is going to be this methyl group now. So we essentially almost think of these as done with, and now the next side chain actually helps us decide when all things are equivalent. So the number 1 carbon is going to be on this side then. So I'm going to have a 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the 7 position, I have the ethyl. In the 3 position, I have a methyl. In the 4 position, I have a methyl. And so to name this then overall, I would call this a 3,4 dimethyl. Put the 7-ethyl in front, alphabetical. And that's a nonane. Almost made that mistake. So the alphabetizing, it is the M for methyl and the E for ethyl. And you might say to yourself, what about the D for di? This is the number of substituents. This is the number of methyl groups. This is the actual functional group or the side chain group. So that's the alphabetized part that we're looking at. So now we go to the next one, and again we have a nonane here like this. Similarly, count from one side, 1, 2, 3. I have a methyl group, 1, 2, 3. I have a methyl group here. So the deciding factor is going to be this carbon. This is going to be the 1, 2, 3, 4, 5, 6, 7, 8, 9. And so in the 3 position is a methyl. In the 4 position is a methyl. And in the 7 position here is a methyl. And I combine them all together. I can say a 3, 4, 7 trimethyl nonane. And that would be it. That's supposed to be an A. So we'll start to complicate the molecules a little more, adding a couple more side chains on. So again, we're going to try to find the longest continuous carbon chain. And if we were to draw a blob around it, we can go down this direction here, which will provide us with 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So we're dealing with a nonane. And now we got to decide which carbon are we starting from, with this side or this side. So we start to count in and take a look at the substituents. We got a methyl group. This is a chloromethyl group and another methyl group. So if I count 1, 2, 3 in, I've got a methyl group. 1, 2, 3 in, I have this chloromethyl. It isn't that there's anything special with it. They're essentially equivalent. So they don't decide which side we're going to start from. This methyl group now is going to decide. So 1, 2, 3, 4 in. This decides that this carbon on this side is going to be the winner. And we're going to start naming from this side. So if I start here, 1, 2, 3, 4, 5, 6, 7, 8, 9 for our nonane. So in the 3 position is a methyl. In the 4 position is a methyl. And in the 7 position is this chloromethyl. So it's a methyl group with a single chlorine. So this is a chloromethyl. And note that this is the substituent. It's not just the methyl, it's a chloromethyl. So we're going to use the C for the naming in this case for alphabetical order. So we can also put a bracket around this to keep it together, although it's not necessary here if we don't want to use it. We don't have to. But you'll find in some cases that it is used. So when I name this then, I'm going to have the chloro come first, and the 2 methyls are going to come together as a dimethyl. So I'm going to have a 7 chloromethyl. Again, you can move this together. Usually you have a bracket if you have some more information in here, like a 1 chloromethyl, but we don't have that, so it's not truly necessary to have that bracket on there. So a 7 chloromethyl, and then this is a 3, 4 dimethyl nonane. Like that. And that finishes that one off. So I'm going to move everything over so we can work on this compound next. So similar to the previous one, the longest carbon chain we're going to find is in this direction here. We have a couple of added substituents here like that. And so the question is, which side do we start from, this carbon or this carbon? 1, 2 in is a fluoro group. 1, 2, 3 in is our chloromethyl group. So this side actually wins now from the fluorine group. And so if we were to continue, this is a nonane. So in the 2 position is a fluoro. In the 3, 4 position is a methyl. So I'm going to say a 3 methyl and a 4 methyl. In the 1, 2, 3, 4, 5 position is a bromo. And then again in the 7 position is our chloromethyl. Starting to run out of room. So this is our chloromethyl. Again, you could put a bracket around it. It's not necessary here, but normally if I were to say have an ethyl group, a 1-chloroethyl, I'd say 1-chloroethyl. And you would typically put a bracket around that so that the 7 doesn't get confused. This is the 7 on the main chain. This is the number 1 position on the ethyl of the side chain. So this relates to this compound. This relates to the main chain. Just realized that wasn't in view, so I pulled it up for everyone so you could take a look. I was saying that the 7-chloro, you don't necessarily need the brackets here for the chloromethyl because that's the only position that the chloro could be on. But if you had a chloroethyl, you could have the chlorine on the 1 position of the ethyl or the 2 position, and so it's more necessary to put that bracket around so you don't get confused. This is the 7 of the carbon of the main chain. This is the 1 of the ethyl group, so we kind of separate those two out. So I'll give myself some room to finish this molecule name. So the bromo is going to come first. The bromo is going to come first, the B, the fluoro will come next, EFGHIJKLM, and the methyl will come next. So I'll put a 5-bromo. Oh wait, I got a chloromethyl up there too. So that's going to come next after the bromo. So here in the 5 position was the bromo. In the 7 position was that chloromethyl. And now the fluoro comes next alphabetically. Even though it's on the 2 carbon, it's alphabetical for naming. And then finally this 3,4-dimethyl nonane to finish it off. See if I can move this over. I keep running out of room. There we go. There we go. So to finish off, we're going to try this compound. So the big thing here is always to try to find the longest carbon chain. So we're going to try a few examples here and see what can make a big long carbon chain. So let's just say we go through as best we can through the middle because that seems to be what people want to do. So we go here like this, 1, 2, 3, 4, 5, 6, 7 carbons. So keep that in mind, go that direction. So we're going to try some other ways to go. So there's more carbon here, so we're going to try this one. Let's see what happens here. 1, 2, 3, 4, 5, 6, 7 again. So it isn't always obvious. Try this direction here. 1, 2, 3, 4, 5, 6, 7, 8. So there's an 8 carbon chain in that direction. We'll take a look at the substituents that are coming off. So in this case here, I've got a methyl group, I've got an ethyl group, but we can see here that I've got this kind of a sec-butyl group, even though sec-butyl isn't necessarily an IUPAC name. We definitely have this. So we'll see if there's another option that gives us, say, an 8-carbon chain in a different direction, but will somehow give us less complicated and more side chains, because we currently have 1, 2, 3 side chains. So the goal is to try to get more side chains that are less complicated. So I'm going to try another way, see if I can do it. 1, 2, 3, 4, 5, 6, 7, 8. So again, 8 carbons in a row, so same as the previous one, but this time I have a methyl, another methyl, and a propyl. And so we've gone from, we had 3 substituents hanging off in a rather complicated sec-butyl group, and now we have 4 substituents hanging off, 3 of them being methyls and 1 of them being a propyl. So this is the continuous chain that we'd like to go for. This is the preferred one that we would like. So let's start naming this one. So if I start from this carbon here, 1, 2, 3 in, I have a methyl group. 1, 2, 3 in is a methyl group. 1, 2, 3, 4 is the propyl group. 1, 2, 3, 4 is an ethyl group. So they're essentially from the same side. So now I have to go back to the alphabetical. 1, 2, 3 methyl, 1, 2, 3 methyl, 1, 2, 3, 4 ethyl. There's an E there. 1, 2, 3, 4 propyl. So it looks like this carbon is going to win out. So 1, 2, 3, 4, 5, 6, 7, 8. Gotta be honest with you that it's not exactly easy getting around this molecule. So in the 3 position, I have a methyl. In the 4 position is an ethyl. In the 5 position is this propyl here, right there in that 5 position. And in the 6th position is another methyl here. So, and I think that's it. That's the 4 groups, 1, 2, 3, 4. And we said now this is an 8 carbon chain, so it's an octane. And let's start naming this. So the E comes first, so it'll be a 4-ethyl. The dimethyl, but it's the M that's important, so the M will come before the P. So I'll go with a 3,6 dimethyl. This is a 5 propyl octane. One thing to note here with the propyl group, a few years ago, I would have specified that you should do a 5,1 propyl because there's a difference. I could have a 5,1 propyl and I could have a 2 propyl. And what that would have been different for me is if I had a chain like this, and if I put a propyl on it, I could show the difference between a 2 carbon chain, or I could show, now bear with me, I'm not counting the carbon, 1, 2, 3. And so I would have said this is a 1 propyl and that this is a 2 propyl. And in the past, I would have differentiated between the two. But the way IUPAC does it now is they just assume propyl is going to refer to the straight chain. So there's no need for an N, there's no need for a 1 anymore. You just say propyl and that denotes that. And then so for the 2 position, you can write it as a prop 2 like that. And so that's telling you that in the 2 position of this propyl group, that's the attachment point to the 5 carbon over here, like that. Okay, so for our final example, we're going to deal with a cycloalkane. So the longest continuous chain is the cycloalkane itself. So there's 1, 2, 3, 4, 5 carbons. So we know that this is going to be a cyclopentane. And now we got to just figure out the substituents. So now, which is the number 1 carbon? So I have a chloro here, I have a methyl group here, and a bromo group here. And the problem is then that we've got, they're essentially equivalent. So the methyl, the chloro, and the bromo are equivalent. So since this bromo is in the middle, this really doesn't help decide anything. It's down to these two. And since they're considered equivalent, I have the C for chloro versus the M for methyl. So the C is going to win out. So this is going to become the number 1 carbon. I could number the ring this way, but as you can see, the numbers are going to be much larger. If I go 1 chloro, 4 methyl, 5 bromo, that as opposed to the 1 chloro, 2 bromo, and a 3 methyl group here. So this is the preferred way to go. So again, in the 1 position is the chloro, in the 2 position is the bromo, and in the 3 position is the methyl. And so if we're to write this out alphabetically, the 2 bromo is going to come first, the 1 chloro will come second, and the 3 methyl will come last. Cyclopentane. And that'll finish it off. All one word, no spaces in between.